Dear students, today we will discuss a second problem when competition is handled between different processes for different resources, and that problem is known as deadlock. So let's see this example. So here is a train A and train B. So you can see that train A is going on this track and train B is going on this track. However, now train B is waiting over here, that train A should go, then it will go to further. And similarly, train A is waiting over here, that when the train B is gone, then it will get a path to go further on this track. So this means A is waiting for B and B is waiting for A. So such a conditions could be invoked in computer systems known as deadlocks. So a deadlock is process A is using, for example, a printer, and it needs something to get information from CD player, and process B is using the CD player and want to print, and both are waiting for each other. So here I'm not saying that process A, which was using printer, has finished using printer and now it needs CD player. I'm not saying that. If this is the case, then it's very easy that it will be assigned CD player when it is free. But I'm saying that when process A is using the printer, then the last instruction of using the printer is associated to get access to the CD player as well. So this means the process A will not be finished until it gets the access to CD player. And similarly, process B will not be finished until it gets the access to printer. So there is another example that there are processes which are allowed to create new space, and such a phenomena is known as forking in UNIX. So if scheduler has no space in the process table in main memory, and each process want to initiate more space, then it means there is a deadlock, because the processes will not be finished, because the process will be finished when it initiates the next process, and to initiate the next process there is a need for the space, and we do not have space. So this means we are again in a condition of deadlock. So if we critically evaluate that how deadlock occurs, so these are the three conditions which are fulfilled or satisfied by a deadlock. So one thing is that there is a competition for non-sharable resources. Then there is a resources are requested on a partial basis. So process A is not asking for printer and all of the way printer. So it is saying partially printer, partially CD player, or if it needs printer, so it is asking printer again and again after some time. So that basically access is partial, and that is having received some resources. A process will turn later to request more, and once a resource has been allocated, it cannot be forcefully retrieved. So as we have discussed about the train example, about the printer and CD player example, and about the process table example. So when the deadlock is there, then no one is able to be revoked from that particular stage. So we need someone external who could revoke or resolve such a situation by killing some of the processes, for example. So in these basically conditions, here lies the answer or solution of deadlock as well. So some of the strategies work on this condition number 3. So they are basically doing deadlock detection. So whenever there is a deadlock, they detect that deadlock and then they kill any of the processes. And there are some other strategies which are working on deadlock avoidance. So they are trying their best and making sure that in future deadlock should not occur anyway. So there are some such strategies as well. So let's discuss one by one. So in deadlock detection, identify deadlocks when there is a deadlock available, and then we need to kill some of the processes in process table, and this killing will be done by the super user like the system administrator, who can kill any of the processes from process table which is basically in the situation of deadlock. However, how to avoid the deadlock? This concept is very interesting. So for example, asking a process to request all resources at once. So this could be one of the strategy. You ask the process that you should not ask or request any resource partially. Do it now, do it once if it is possible. Or giving access to every time it asks. So for example, if you know that printer is not available and it is being used by process A, and process B also want printer, so give printer to process B. You will be surprised at how we can give the printer to process B when it is being already used by process A. We will create an illusion. We will not give the actual printer to process B. In fact, we will say that we will communicate the process B to the controller. So you know that there is a controller which is communicating with the printer. So we will say the controller, okay, please act as a printer, get all of the information from process B, whatever need to be printed, and tell the process B that your task is done, you have printed your document, and please go with your further procedures so that there is no deadlock. And once process A will stop using the printer, the controller will send all of the required information from main memory or mass storage to the printing device, and seamlessly it would be a way that process B will not know that it has not communicated with the printer and it has not given the chance of the printing. So such a concept is known as spooling. So involving controller to act as a device. So if we conclude today's module, we have learned another very important problem of deadlock when different processes are competing for different resources. And we have done the examples, we have seen the conditions, and based on the conditions, we have learned that how the deadlocks can be detected and how the deadlock can be avoided.